is directly addressing the memory wall sort of issue, which is going to be the primary problem in sort of scalar systems. And on the I side, the edge profiling mechanisms, lot of work has been done with like instrumentation-based mechanisms, and this just uses the performance monitoring unit to do the edge profiles. And there's lots of optimizations. I'm not going to sort of like read through each one of them, which is actually going to be possible, and some of them are possible today with software techniques. Okay, so that's the second idea. And the third idea is one I think that's been brought up a couple of times already at the workshop. So you have sort of production runtimes that provide execution of one virtual ISA onto one host ISA. So it is Java bytecode that's running on i32. And so some of our customers have sort of requested us to help solve sort of a problem for them where sort of interoperability between host ISAs is sort of very transparent. So you have a situation where a 32-bit JVM is calling an i32 library. So it's a mixed mode application. It's not just all pure Java. And that needs to be able to run seamlessly on IPF. And we have a binary translator from IPF to i32. So how do you put the binary translator together with a managed runtime? So that's the thing here. So we have been sort of looking at both problems, not in as much detail in both cases, but some work has just sort of gotten started. So this is again in the lab where the Starjet architecture is basically taking both Java bytecodes and CLI bytecodes and translating into common typed IR and taking it all the way to the back end. It also has the same mechanism as in the product, which is the profile-guided feedback optimization. So here, this is the loading and executing i32 libraries in 64-bit managed runtimes. And this is, I don't know how much of this will be a problem in other places, but I think the isolates model is going to be, this is not an isolate sort of based model. This is all in the same process. But it's going to be important when you actually start having 64-bit libraries with Intel CM64T or AMD's x86 64 and 32-bit JVMs to be able to interoperate. So you'll start having the same set of problems at multiple places. So here what we do is we have a little layer that's sort of a bridge that gets initialized when the managed runtime loads up. This is again done within the JRocket system. There's a prototype. There's no product with this yet. And this in turn loads the i32 emulator, which is the binary translator that we have from. It's basically another virtual execution environment that executes from i32 to IPF. It converts to IPF native code. So this also solves sort of the potential of jitting your if you run the whole, today you could run this whole sort of mixed mode layer directly on top of the i32. Yeah.
Itanium had this fancy instruction that says jump and switch instruction set interpreters that would, running an 64-bit mode, jump and start executing an x86 instruction.
Yeah. So in the newer Itaniums, that hardware stuff is going away and it's getting replaced with more and more software.
You're just using a binary translator since that's going away. Would that instruction actually have worked here?
The problem is that the 64-bit pointer is coming in, so we have to translate that into 32-bit representatives. I mean, in the 64-bit world, everything is 64-bit pointers, and he's calling native code that uses 32-bit pointers. So there has to be some sort of translation of it.
Before you jump.
Yeah.
you want a direct jump to 32, you translate first, all the pointers.
Yeah, there's a little, so what we do today is there's a little stub that we jump to and call the I-32 ELN, which loads the I-32 library. There's a lot more work for doing the down calls are sort of easy, but doing the up calls where you want to be able to go back from the 32-bit library back to the 64-bit Java is a lot more harder. I'm actually illustrating that here. But this is all done completely without using any of the hardware I-32 features in IPF, just using the software here. What else? What else is here?
You're assuming that the VM is running in a mode where it's been told ahead of time you keep pointers in at low addresses or something. But I guess it doesn't matter, as long as you only have native code down there.
Okay, I didn't quite.
I was just wondering about avoiding passing 64-bit pointers down. You have to make sure somehow that you can't compress the 64-bit to 32.
Right. So this layer here is the one that actually takes the 64-bit pointer, and it uses a stub routine to do this conversion.
Okay.
So it's done there. Actually, the backward there is more sort of issues with thread local storage and all sorts of other things that I didn't sort of go into here, but all that is working.
So you don't have to constrain the VM to 32 bits, really. It can actually use it in
It can use, yeah,
okay.
it can use, although we haven't actually sort of run really large applications on this yet, so we might start finding other issues.
You just have to, you still have to ensure that any data you pass is reachable in 32-bit address, by 32-bit address.
He's converting everything to 64
Yeah,
bit.
everything is getting converted.
It's never
finally.
executing a single byte of 32-bit code.
So this basically
That's
converts
what
everything
translates
to
it.
IPF
Yeah.
instruction. So the whole execution is still sort of running in 64.
Right.
Ergo that we don't call the other mode.
Right, it's depending on your definition of running.
Yeah.
So in terms of the future, I think Mendel mentioned this. So Intel has technology called the Vanderpool technology, VT, and it's also available now in the Itanium family for doing hardware-based virtualization. So with that, sort of the usage model is also going to potentially change, where you have maybe on these multi-CPU machines, you're actually running maybe 3 or 4 different OSs, and then your managed runtime is actually running now, rather than sort of OS and hardware, the sort of three layers away. So it sort of leads to other interesting opportunities that we need to sort of solve together. Is how are these, if you want to do hardware-based profiling, how are these counters virtualized, and sort of are you really getting the right kind of like data? So there's all sorts of interesting problems. But it's not going to happen sort of like tomorrow. It's going to happen in the next couple of years. But there's an important problem that we as a community needs to deal with, unless Azul Systems hardware replaces everything. So I think in terms of the hardware support, we saw from them that you have performance, a lot more performance, but there's going to be all these other aspects of security or reliability that managed runtimes require, and we need to start telling the hardware people and work together as an industry to actually make that happen as to what is exactly needed. So the dual core, multi-core, that's already coming. I guess there was an announcement at the Intel Developer Forum where they kind of showed, probably the slides are available publicly, where they showed sort of the trends for what happened with HT and when it was introduced, and it took about 3 to 4 years to get to about 70% penetration rate, and so they're kind of estimating similar figures. So you have a couple of issues. I just sort of brought it up at a high level, but this I think this whole area is something that we need to spend a lot more